Alrighty, friends, let's make a key for this spiral. So Mrs. Key. Identify two expressions that represent this pattern. Alright, so let's talk about what we see. So you need to list what you're seeing going on. So I can see there's one big column, there are two big columns, there are three big columns, and there are four big columns. So there are n big columns. And let's see, this column is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And then I'm going to guess that's 8. So that's just n big columns that are n plus 4 big, or n plus 4 long. So if I do 1 times 1 plus 4, I get 5. If I do 2 times 2 plus 4, I get 2 times 6, which is 12, which is how many are there. If I do 3 times 3 plus 4, which is 7, so that's 21. There should be 21 there. 1, 2, 3, 4, 5, 6, 7. Yep, 21. And then I also need to add on 2, 1, 2, 1, 2, 1, 2, and 1, 2, n. So that's one pattern. n plus 4 plus 2n. Now in the spiral, you're only going to have to come up with 1. But I got to come up with 2. So my second one, if you haven't come up with the second one, you should try to come up with the second one right now. Let's see. Perhaps my second one is, let's box this thing out. So if I make this whole thing, this is 3 by 1, 2, 3, 4, 5, 5. And then this is 4 by 1, 2, I already know that, 4 by 6, 5 by 7, and 6 by 8. So those are going up by 1 on both of those. So 3 is 2 bigger than 1. 5 is 4 bigger than 1. So 4 is 2 bigger than 2. 5 is 2 bigger than 3. Okay, so that expression makes some sense. And then 6 is 4 bigger than 2. 7 is 3 bigger, so that makes some sense. But I need to subtract out these pieces. So that's a 1 by 2, 1 by 2, 1 by 2, 1 by 2. So that's 4 1 by 2s. 1, 2, 3, that's also 4. Oh, so it's just 4 1 by 2s each time. So it's 8 blocks, so minus 8. Because 4 1 by 2s is 4 sets of 2, which is 8. All right, describe the pattern as linear, quadratic, or exponential, or neither of these. Well, let's see. I'm guessing they're talking about the total number of blocks. So the total number of blocks, 5, 6, 7. And then that was 12, 13, 14, 15, 16. And then 21 and 6 is 27. So that's up by 9. That's up by 9. Oh, so it's a linear kind of move there for the total number. Wait a minute, that's not 9. That's not, I was confused because that didn't look like a linear pattern. That's 11, silly me. And then 4 by 8 is 48, plus 8 more is 54. By 54, I mean 56. All right, so then that's up a whole bunch more. So that's definitely not linear. It doesn't really seem quadratic. And we're not multiplying by the same thing each time, are we? 16 sevenths? No, because that wouldn't work. So I'm going to go with none of these because it doesn't fit any of the patterns. The linear one would have to go up by like 9 each time. The quadratic one would have to go up by increasing amounts, but they would be understandable. So like a quadratic one would be like x squared. So 1 squared, 2 squared, 3 squared, 4 squared. So that goes up by 3, that goes up by 5, that goes up by 7. So something that's kind of a predictable pattern there. And And exponential would be multiplying by something. We're not multiplying by the same thing each time. So I'm going to go with none of these. Algebraically prove my expressions are the same. Okay. So I have n plus 4 plus 2n. And I have n plus 2, n plus 4 minus 8. So let's give me some more room for this. And let's start on the left. So we have n plus 4, so I get to distribute. Pew, pew! That's n squared plus 4n plus 2n. So that's n squared plus 6n. Alrighty, and then over here, hoping for n squared plus 6n. Got to double distribute, so multiply those and multiply those. That'll be n squared plus 4n plus 2n plus 8 minus 8. So I got n squared plus 6n. Oh, they're the same. Look at that. Beautiful. And then on the last question, that wasn't letting me do what I wanted. The last part says, use Desmos to show the expressions are equivalent graphically. So what I should put in is x plus 4 plus 2x, and x, not n, x plus 2, x plus 4, and then minus 8 to show that those are accurate and the same. Oh, I wrote an n there. Not an n there. Put those into Desmos, and then copy and paste your graph. I will do that on Edpuzzle, but copy and paste your graph. Okay, let's figure this one out too. That's not letting me do what I want, so let's change that. Okay, we've got x minus 5, x plus 3 with a 2 in front. So I know this is going to be an up parabola, and it's going to have the point 5, 0, because if I think of x minus 5 equals 0, if I solve that, I get x equals 5. And negative 3, 0. For the same reason, x plus 3 equals 0. Solve that, you get x is negative 3. So on the quiz, feel free to put it in Desmos and paste it, or you can just draw it. So my picture is going to be something like this. 5, 0, negative 3, 0. And it's going to be up parabola. So I didn't even need Desmos, and you may not need Desmos. But if you need Desmos, it's there for you to support you. So are we concave up or concave up? We are concave up or concave down? We are concave up. We are concave up because we have a positive 2 in front. If that's a negative 2, then we are concave down. What are the x-intercepts? So that's where we cross the x-axis. I already figured those out. 5, 0, negative 3, 0. If you're struggling on that, Desmos can help you with that. What is the axis of symmetry? Okay, so that's got to go through the middle here. So I can just think of this as I have 5 and negative 3. The middle of those is 1. If you don't believe me, to find the middle, find the average. 5 plus negative 3 is 2, divided by 2 is 1. So the x value of the vertex there is going to be 1. You can find that on Desmos also. But the axis of symmetry is the equation of the line that goes straight up and down through the middle of your parabola. And then the y-intercept, well, Desmos could tell me that, but I can also just plug in 0 for x. So that's 2. 0 minus 5 is negative 5. 0 plus 3 is 3. 2 times 5 is negative 10 times 3 is negative 30. So 0, negative 30 is my y-intercept. Write these as points, please, because I want to see them as points. We want to see them as points. Alrighty, analyze the graph. Describe whether each function can be used to model the graph. So when I'm analyzing the graph, I'm looking at the graph and I'm saying, okay, I notice that we have 2 x-intercepts. I notice that we have concave down. Concave, forgot how to spell. Down. So both of these are concave down, so we have checked that off. Oh, I also have a vertex. Vertex, that's got to have a positive x and a positive y. How do I know that? Because up here, the x value is positive and the y value is positive. So positive x, that's supposed to be a positive y. So let's see, the vertex for this one is negative 6, 2. That is a negative x value, so that cannot be that graph. Cannot work. And then the zeros here are -5, 0, and -8, 0. I need positive x-intercepts. I have negative x-ins. So cannot work. The more explanation you can provide, the better. And since this isn't a Jamboard, if you want to provide the explanation as either written in text or on a sticky note, instead of having to write it down, that's totally fine. You don't have to handwrite it. You can just type it in. But those are the key pieces. So pay attention to the x-intercepts, if there are any. Pay attention to the concavity, whether it's concave up or concave down, which is the number in front. And pay attention to where the vertex is. You could use Desmos to help support you, but I think we will be relatively comfortable with this.